Suppose we have a circuit like this and we are asked to calculate the currents in the branches here in this circuit. Well, here it looks like a complicated circuit, but it's not. We modify it a little bit to make it easier to understand. And I'm going here to use only the current divider to calculate all the currents. I will explain what is the current divider. If you remember, current divider, when we have two resistors in parallel, we can calculate the currents in the branches using the main current, which is here. How do we do it? Well, we use the Ohm's law. E1 is equal to V over R1 and I2 is equal to V over R2. Knowing that V is equal to the equivalent resistance times I, it means that it's R1 R2 over R1 plus R2 times I. So we can replace V in this expression and we get this expression, following expression, in function of the main current. So we are going to use only current divider to calculate all the currents. So it means if we know this current, we can calculate I3 and I5, knowing the equivalent resistance of this. So we can call this one R, I don't know for the moment how I would call it, or if we use subscripts, we will use R4, 6, 7, 8, 9, 5 to calculate I5, and here R1, 2, 3 to calculate I3 and I5. Okay, let's start to calculate first the main current. Knowing the main current, as I said, knowing the main current, I can calculate I3 and I5. Knowing I5, I can calculate I6 and I4. Knowing I6, I can calculate I8 and I7. And knowing I3, I can calculate I1 and I2 using the current divider. Okay, let's go. Now calculate the equivalent resistance of this circuit. Let's start from this part of the circuit. We have R6 and R7 that are in series. First step. Second step, we have R8 in parallel with R9. This is second step. Third step, we add the two. They are in series. The third step. The fourth step is that these are in parallel with R4. This is the fourth step. The fifth step, we add R5 because they are in series. And we add R5, and now R1 and R2 are in parallel. And in series with R3. This is sixth step. Seventh step, we add R3, and these are in parallel with this, and this is our equivalent resistance, and we finished. Now, instead of using the subscript, I will call them R1 prime. This is R6 plus R7, and this is 85 plus 200, it's 285 ohms. R2 prime, this is R8 in parallel with R9, this is 100 times 85 over the sum of these two, and is equal to 45 point, there's point here, not comma, 0.946 ohms. R2 that are in series, which is R1 prime plus R2 prime. This is 285 plus 45.946 is equal to 330 times 0.94 ohms. And here we can calculate R4 prime. This is R3 prime in parallel with R4, and this is 330.94 times 77 over 330.94 plus 77, and this is 62.465 ohms. And we go to R5 prime, we add R5 to R4 prime, and this is will give us 62.465 plus 50, and this is 112.965 ohms. R6 prime now, 6 prime is R1 times R2 over R1 plus R2. This is 25 times 50 over 75, and this is 16.67 ohms. We go to R7 prime, R7 prime, this is R6 prime plus R3, and this is 16.67 plus R3, 63, that will give us 79.67 ohms. Now we calculate R8 prime. This is R7 prime in parallel with R5 prime, and this is R7 prime times R5 prime over R7 prime plus R5 prime, and this is I will give you the result. This is 79.67 times R5 prime, 112.465 over the sum of the two. I'll give you the result. This is 46.635 ohms. From this we can calculate the main current. Main current is V over the equivalent resistance, 100 over 46.635, and this is 2.144 amps. We write the result here. I is equal to 2.144 amps. And what I need here R7 prime. I write here 79.67 ohms. I will need R4 prime, is that right? R4 prime, that's right. R4 prime is needed, we will see. R4 prime is equal to 62.465 ohms. What else do I need? I need R5 prime. R5 prime is 112.465 ohms, and I think it's what I need to calculate all the currents, knowing the main current. Now let's calculate the other currents in all the branches. So knowing, as I said, knowing I3 and I5, knowing I can calculate I5 and I3. What we need here is R5 prime here, the equivalent resistance of this and the equivalent resistance of this to calculate I3 and I5. So it means that I3 is equal to R5 prime over R5 prime plus R7 prime times the main current. I5 is R7 prime over R7 prime plus R5 prime times I. So let's calculate I3. I5 prime is equal to 112.46 over 112.46 plus R7 prime plus 79.67 times the main current, and here it's 79.67. I don't need to do it this way. For this current I can take away I3 from the main current and I obtain I5, but we can use this as well. 67 times 2.144, and the result is this one. I will write the result, I3 and I5. I3 is equal to, let's calculate it, 112.46 plus 79.67, 1 over this times 112.46 times 2.144 will give us 1.255 amps minus 2.144, and here 0.89 amps. Okay, I calculated I3, I5. I can calculate I1 knowing I3. I can calculate I1 and I2 in function I1 and I2 in function of I3. This is R2 over R1 plus R2 times I3, and this is R1 over R1 plus R2 times I3, and this is R2 is equal to 250 over the sum times I3, and here is 25 over 75 times I3, which is equal to 1.255, and is equal to, write them here, I1, I2, 75 times 50 times 1.255. This is I1 is 0.836 amps minus 1.255. This is 0.42 amps. That's it. I calculated I1 and I2. Let's go back to this circuit now. Here we need I4 and R7 prime. Is that right? No. This is called R3 prime. R3 prime here. R3 prime, we need to calculate I6 and I4. I6 is equal to I4 over R3 prime plus R4 times I5, main current. I4 is equal to R3 prime over R3 prime plus R4 times I5. This is R4 is equal to 77 over 77 plus R3 prime. R3 prime, I didn't write it down. R3 prime, what is the value of 330, I forgot to write it down. 330.94 times I5, 0.89, and here over the sum. Okay, this is 77 plus 330.94, 1 over times 77 times 0.89, and this is I6 is equal to 0.1168 amps minus 0.89 I4 is equal 0.722 amps, and we are left with I8 and I9 to calculate, and we finish our exercise. It means I8, I9 in function of I6, this is R9 over R9 plus R8, R8 over R9 plus R8, this is 0.168, and here we have R9, which is 85 over 185, here it's 100 over 185, and that gives us a current of 85 divided by 185 times 0.168. This is 77.2 milliamps, minus 0.68. This is 90.81 milliamps. I hope that I haven't made any mistake. If I had made a mistake, it means that the method is good. You can always correct the results. You see, it's not complicated. You go step by step, and we can calculate all the currents flowing in the branches. And thank you very much.